Good day. My name is John Ronnie Tadeo. Today, I'm excited to share with you some insights that I've learned on a critical topic in our field addressing misconceptions in teaching English language learners. This presentation is about addressing misconceptions in teaching English language learners, or ELLs. As a math teacher, some might think this doesn't apply to us, but I assure you, it's crucial for all content areas. Now, let us dive into the heart of our discussion. There are four common misconceptions about teaching ELLs that we need to address. First, exposure and immersion are the answer. Second misconception, one size fits all. Third misconception, just good teaching is enough. And fourth misconception, effective instruction means nonverbal teaching. Today, we're going to focus on the first misconception, the idea that exposure and immersion are enough. This is particularly relevant to us as math teachers because we often assume that the universal language of mathematics will be enough for our ELL students. Many of us believe that children will automatically learn English given enough time. This belief often stems from our understanding of first language acquisition. We think, well, kids learn their first language just by being around it, right? But this ignores the needs for specialized instruction. I want you to think about your own experience. Have you ever had an ELL student who seemed to understand spoken English well, but struggled in academic language and math? That's because exposure alone isn't enough. Now, let's explore why this misconception is so common. There are three main reasons. First, we draw a parallel to first language acquisition. We see how effortlessly children learn their first language and assume second language acquisition works the same way. Second, we underestimate the time required. Learning a language takes years, not months. Third, there's a lack of awareness about academic language needs. Conversational fluency is different from academic language proficiency. In my math class, for example, I might hear an ELL student chatting easily with friends and assume they can understand complex word problems just as well. But that's not always the case. Let's look at some numbers that highlight why exposure alone isn't sufficient. By age 5, a child has had over 25,000 hours of exposure to their first language. In school, students get about 1,000 hours of exposure per year. So our ELL students are starting with significant deficit in terms of language exposure. Moreover, Stephen Krashen's theory of comprehensive input suggests that language acquisition occurs when learners receive language input that is just beyond their current language ability. In my math classes, for example, if I'm not consciously providing comprehensible input, I'm not helping our ELL students acquire language effectively. Lastly, academic language instruction is crucial. In my Algebra 2 class, for example, we use terms like quadratic functions, vertex form, and complex roots. These aren't terms ELLs will pick up through casual conversation. So how do we address this misconception? There are three key steps. First, educate ourselves and our colleagues about the differences between first and second language acquisition. Second, highlight the importance of specialized instruction. This doesn't mean dumbing down the content, but rather making it accessible. Third, emphasize the needs for academic language development. In math, this means explicitly teaching mathematical vocabulary and language structures. Now, let's get practical. How can I apply this knowledge in my own Algebra 2 class? Here are some strategies I will be implementing. First, I will be using visual aids and manipulatives. For example, when teaching parabolas, use a physical parabola or a dynamic graphing tool to show how changing coefficients affects the graph. Second, incorporate language objectives along content objectives. For instance, students will be able to describe the transformations of a parabola using academic vocabulary. Third, provide sentence frames for mathematical discussions. For example, the parabola is translated 5 units up or down and 3 units left or right. Fourth, encourage peer discussions in both first language and second language. Allow students to process complex concepts in their native language before expressing them in English. Let's spotlight one strategy. Think, pair, share. Here's how it works in algebra 2 context. First, introduce a complex algebraic concept, like solving systems of equations. Number 2, give students time to think individually. They can process in their first language if needed. Third, have them pair up to discuss. Again, they can use their first language if necessary. And finally, they share with the class using provided language structures. This strategy allows for processing time, peer support, and structured language practice. By implementing these strategies, we see several benefits. First, accelerated English language acquisition. Students learn academic English faster when it's explicitly taught. Second, improved academic performance across subjects. The language skills they learn in math class transfer to another area. Third, boosted student confidence and participation. When students have the language tools, they're more likely to engage. Fourth, preparation for long-term academic success. We're not just teaching Algebra 2, we're building a foundation for future learning. To wrap up, let us remember 3 key points. Number 1, recognize the complexity of second language acquisition. It's not just about exposure. Number 2, implement targeted strategies in our content areas. As a math teacher, I have a role to play in language development. Number 3, continually educate ourselves and others. The field of ELL education is always evolving, and we need to stay informed. Thank you for listening and have a good day.